Okay, so on this video, we're going to be talking about compound inequalities and specifically compound inequalities of OR. Okay, so I'm going to blow this up really quick. OR inequalities have a tendency to graph separate or away from each other. All right, and you'll see what I mean here in a second. All right, so this first example, we've got x is less than or equal to -2. So obviously, it's got a line underneath, so we need to put a closed circle on -2 right here. Pointy part is facing the x, so we're going to shade left this way. Meaning, yeah, we're going to put these on the same graph. Now what we're going to do is we're going to graph the other one. Or x is greater than 3. So there's no line on that one underneath. So this one's going to be an open circle on 3. So there's 3, open circle. Big mouth is facing the x, so shade right. And here you can clearly see that the two inequalities graph separate from each other. There's a space in the middle that is not part of the solution. All right? So let's go to number 1. All right? These are called OR compound inequalities. So we're going to have two problems, basically, that we need to solve when we're going to graph both of them on the same graph. So on the first one, this one's pretty simple. So you can draw a line here and split them in half and then do both problems. Okay, that way you keep them kind of separated. So on this first one, we're going to add 4, meaning this is a pretty simple one-step problem. We get x is less than -3. So that's my first answer. Now let's go to the other one. Divide by 2. X is greater than or equal to 6. So we got two answers. We're going to plot them on the same graph. An OR graph should graph separate like what we have right here. If it doesn't graph like that, then you either solve the two problems wrong, your symbols are wrong, meaning your inequality symbols, or you graphed it wrong, meaning, yeah, you could have made a litany of possibility of mistakes. All right, so let's graph the first one. X is less than -3. So that's going to be an open circle on -3. Pointy part is facing the x, so we're going to shade left. Right here. All right, now let's do the other one. X is greater than or equal to 6. So we need to find 6, and this one's going to be a closed circle on 6. Big mouth facing the x, so we're going to shade to the right. So obviously, this would be a correct OR graph. Right here. One thing I forgot. Interval notation. So let's go back to... Actually, let's not go back to the example. Well, yeah, we will. Let's go back to the example. Okay? So on the first example, up here on the interval notation, you're going to have two graphs. So two graphs means two notations. So we're going to do this first one on the left. So the x is less than or equal to -2. So my graph starts right here at -infinity. Okay, that's not a very good infinity sign. Let's try that again. All right, which is always a parenthesis. It stops at -2, which is a bracket. Now we have to do the other one. So this one starts at 3, which is a parenthesis, and it ends at infinity, which is a parenthesis. Two graphs, two notations. All right, so now let's do the notation of this one. So this one starts at negative infinity, which is always a parenthesis, and it ends at negative 3. Open circle means parenthesis. This one starts at 6, and it's a closed circle, which means bracket, and it ends at infinity, which is always a parenthesis. So OR graphs are going to always have, or should always have, two notations because they're going to be two graphs. You have two separate graphs. All right, so number 2. Here we're going to divide by a negative 3, which means that we need to flip the sign. And negative over negative is a positive. All right, so there's my first answer. This one, I need to subtract the 5. That's now gone. I get x is less than 1. All right? So now let's go graph it. So right here, let's do the first one. Closed circle on 3. I'm going to blow this up just a little bit. Closed circle on 3. Big mouth facing the X, so we're going to shade to the right. Like so. Alright, so now let's do the other one. This one's going to be an open circle on 1. So open circle on 1. Pointy part facing the X, so we're going to shade to the left. Like so. And you can see that there's a little bitty space in the middle, and we do have two separate graphs. So we're going to have two separate notations. So this one starts at negative infinity, which is always a parenthesis. It ends at 1. Open circle means parenthesis. So now we need to do the second notation. This one starts at 3. And it's a bracket, because it's closed circle, and it ends at infinity, which is a parenthesis. Solve graph notation. Still 3 things that we're doing. All right? Number 3. So this one right here, we got two-step equations. So here we're going to subtract 9. Go ahead and draw my line to separate these two. So we get 2x is greater than 8. Divide by 2. X is greater than 4. So there's my first answer. Here I'm going to subtract 10 to the other side. Don't be fooled by this. 10 minus 10 is 0. All right. Divide by 5. X is less than 0. Okay. So we got our 2 answers. So now, first one, open circle on 4. Big mouth, make this a little bigger. Big mouth facing the X, so that means shade to the right. All right, the other one is open circle on 0. Let's make it a better open circle. Open circle on 0. Pointy part facing the X, so we're going to shade to the left. So again, clearly this is a correct OR graph. OR should always be 2 separate graphs. All right? Notation. This one starts at negative infinity, and you don't have to draw the arrows like I'm doing. Okay, I'm just doing it just to show you. This one ends at 0. Open circle means parenthesis. This one starts at 4, open circle means parenthesis, and it ends at infinity, which is always a parenthesis. All right, number 4. So again, we've got two-step equations. So on this first one, what we're going to do is we're going to add 14. we get 7x is greater than or equal to 14. Divide by 7, x is greater than or equal to 2. So there's our first answer. Here, we're going to subtract 5. We get 4x is less than or equal to negative 8. Divide by 4. X is less than or equal to negative 2. So there's our other answer. All right. So x is greater than or equal to 2. So close circle, because there's a line underneath, on 2. So let's go to 2. All right. So close circle on 2. Let's scroll back here. And big mouth is facing the x. So we need to shade right. Now let's go to the second one. All right, so closed circle on negative 2. And pointy part is facing the x, so we're going to shade left. And clearly it is an OR graph. They're two separate graphs away from each other. All right, so interval notation, two graphs, two notations. First one starts at negative infinity, and it goes to negative 2. Don't forget, closed circle means bracket. The second one starts at 2, and it goes to infinity, like so. Last one for the ORs. So we got a little bit more problem right here. So obviously on the left side, we're going to have to distribute because we see a parenthesis. So negative 3 times 2x is negative 6x. Negative 3 times 1 is negative 3. Drop that down. We're going to add 3 to the other side. We get negative 6x is less than negative 12. And watch what we're doing here. We are dividing by a negative 6, which means we need to flip the sign. Negative over negative is a positive. 12 divided by 6 is 2. So x is greater than 2. Got to make sure to watch dividing or multiplying by a negative. All right, so now we go on the other side. We need to get rid of that 1 first. All right, so that's now gone. We get negative x. It's greater than or equal to 4. And yep, you guessed it. That's technically a negative 1. So we're going to divide by a negative 1. Keyword is divide by a negative 1. So that means we have to flip the sign. And 4 divided by negative 1 is negative 4. So there's our answers. So we're going to plot an open circle on 2, and big mouth is facing the x, so shade right. So open circle on 2, and shade right. All right, for the second one, we're going to have a closed circle on negative 4. Pointed part is facing the x, so we're going to shade left. And we have a correct OR graph. Like so. Interval notation. So do the one on the left first. So it starts at negative infinity, which is always a parenthesis. It ends at negative 4. Closed circle means bracket. Now we're going to do the one on the right. Starts at 2. Open circle means parenthesis. And it goes to infinity, which is always a parenthesis. So what you have at a glance is the compound inequalities that are OR problems. They always, and you can see every single one of them, they're always going to be two separate graphs with a space in between. And they're all going to have two interval notations.